Oh yeah, screen just filled up.
Wow.
Hello,
How many
everybody.
people do we have?
So far, we have 42.
Okay, that's pretty good.
Okay, cool. Hey, everyone. Thanks for joining us and thanks for your patience as we kick this off. Typically, in the
Thank you
first
so
week-
much, everyone, for coming out to join us today. We're really excited. Do we want to get started, Parsa, or do we want to,
Let's-
how about we ask
yeah, let-
Pat, are you comfortable if we record this session so that like other people who aren't able to join can watch?
That's fine with me. Yeah.
Awesome. Okay, so Parsa, if you want to get recording so that we can put this into history.
recording is good to go.
Okay, awesome. That's great. Are we ready to start, Parsa, or?
Yeah, let's kick it off. I think this is,
Okay.
yeah.
Awesome. So thank you everyone for taking the time to come out here. We really, really appreciate it. We really appreciate our speaker, Pat, for coming out today. He is our 15th Turing Award winner to come out. He is the last speaker that we have. We're very excited. I'm going to give a very brief synopsis, and really we're going to allocate all the time to Pat so he can talk. But very briefly, according to Wikipedia, he is an American computer graphics researcher, the Canon USA Professor of Computer Science and Electrical Engineering in the Computer Graphics Laboratory at Stanford. His research focuses on rendering algorithms, graphics processing units, as well as scientific illustration and visualization. He received numerous awards, including the 2019 Turing Award. He is a co-founder of Tableau, which was acquired by, I think, Salesforce in 2019 for about 15.7 billion. She's our first billionaire to present. If everyone can give a massive round of applause for Pat, we are so grateful to have you today.
Thank you. I recognize a bunch of names that I know, so thank you for coming.
Awesome.
Do any, we usually kick it off with our own questions, but if any of the names you recognize have any that they want to kick it off with, they're welcome to unmute and jump in too. Raise their hand, we can call on you.
Right. I mean, well, yeah, we can get started with like a question. My question is going to be the least technical of everyone's. I'm curious, like, I guess, what your involvement was in like Toy Story, for example, which is like for I think maybe a lot of us here in the chat, we grew up with the movies such as Toy Story and other films in being such a critical piece in being a founding employee of Pixar. Can you tell us a little bit about like what it was like to be involved in such like a tremendous, impactful animation movie stuff?
Yeah, thanks for the question. Yeah, so well, first of all, I wasn't working at Pixar when they produced Toy Story, so
Okay.
my involvement was sort of, indirect. But I worked there. Pixar had a long journey. I mean, the company was founded in 1986, I think, and then Toy Story came out in 1995. And they were sort of trying to find their path, and they eventually signed this contract with Disney, which led to Toy Story. But most of the time when I was there, they had spun out of Lucasfilm and they were going to build graphics hardware. We had something called the Pixar Image Computer. So my first job there was to be the software product manager of the Pixar Image Computer. And then I started the RenderMan project, which was, we were just trying to figure out, we were a startup owned by Steve Jobs. He put in a lot of money and, we weren't making much money. So I started the RenderMan project, in order to try to find a product that would at least generate some revenue, because it was just such an incredible place to work. I was just a little worried that, we might go out of business. And, having 10 years before you're really big success is a long time, a long ramp up time. So anyways, but I worked on RenderMan but I wasn't involved in the actual production of Toy Story. I did go to the premiere of Toy Story, and I have one really fond memory of that, which, I'm a nerd. I'm sitting, we're computer scientists, we're hacking all day, writing software, trying to debug, artifacts and images and whatever. And, I was so focused on my job, which was just to make this rendering software production, quality, that if you've ever been involved in any kind of movie thing, you get these very small, short scenes, and you're working on little things and they send you these bugs or whatever, and you try to figure it out, but you don't really get the big picture. And when I went to the premiere, it was a great movie. I said, wow, this is a really good movie. I mean, normally when I go to a computer-generated movie, I'm looking for all the artifacts in the images and, what new technologies they're using. But the movie was just such a great story. And I remember after it, walking out, and everybody had all their kids there, and all these kids were just like smiling like you've never seen before, And so, that just made this huge impression on me because, you develop technology, to do good and to bring pleasure to people and make them happy. And that seemed to be more satisfying than fixing all those bugs. So it was I was really fortunate to be part of all that.
That's really awesome. Is it said on Wikipedia that you're credited with, it said on Wikipedia that you are credited in Pixar productions, including Toy Story. So that's the thing.
Yeah, well, they did. I mean, partly because it was such a long road to get to the movie, to finish the movie. They were very generous in including a lot of people that may have left or gone on to other things, and so I was lucky enough to get a credit. But I still am very close to a lot of people at Pixar. And in fact, we just received last year or the year before, we got this IEEE milestone for RenderMan, which was this plaque that they put outside it, just just recently installed. And it was, it's just great to go back there, and a lot of people I know still work there, and
wow,
it's just a great place. Yeah.
Wow. Okay, so Parsa, do we want people to raise their
I'm going to jump in really fast because we do have a comment from Vasant Onever, which says, "Hi, Pat. Good to see you. If you don't mind, please share your personal journey, starting with the early schooling in Milwaukee. I think it'll be inspiring for the students in the audience."
Okay, well, Vasant, I know because I think we shared the same advisor, PhD advisor, Leonard Ure. So yeah, it's a long journey. I mean, I started out in physics at the University of Wisconsin in Madison, and I was actually in an honors program in physics, which was awesome. And because I was in the science program, got to take all these courses in other areas besides physics. So I took a bunch of biology courses, and one that I particularly liked was about neurobiology, taught by my co-advisor, actually, Tony Stratton. And we worked on simple nervous systems. And then I met Leonard Ure, who was in the computer science department, and he was working on computer vision, and he was working on neural nets, somewhat surprisingly. This is in the period, maybe the dark ages of neural nets. Neural nets had been around. I learned about them in grad school. I mean, they go back to McCulloch Pitt, I think in 1939. And they've been around for a long time. And Len always liked them. I mean, he just spent much of his career working on neural net technologies, including some crazy stuff like he called neural symbolic computation at the time. But anyways, he was trying to train them. I think Vasant has a very famous paper about how to train the weights on neural nets, which he wrote around that period of time. Correct me if I'm wrong, Vasant. But anyway, my first job was actually programming neural nets on some image processing hardware. We were very interested in parallel computing. Len, my advisor, was a really big parallel computing guy. He was interested in building AI machines because he just, realized it would take an incredible amount of computer. So I actually learned a lot about parallel computing from him, particularly parallel image processing and parallel graphics, which turned out to be a really big thing in my later work. Yeah, so I wrote I gave a talk recently. I still showed a program I wrote for this image processing machine that implemented neural nets, which was, I think, in 1982 maybe, or something like that. I don't know, something like that. Anyways, so it was a really great thing. And then, but during that period, because of the image processing work with Len, and because my roommate, a guy some of you may know, named Paul Haberly, introduced me to computer graphics. And I was working on neural nets and also sort of simulating nervous systems. And so I got into some visualization and computer graphics, but then I just got completely hooked on computer graphics. Left the PhD program, went to a place called NYIT, New York Institute of Technology, and sort of immersed myself in computer graphics. So I don't know, I can go on and on about the various turns in my life, but yeah, it was sort of an interesting background being in AI, and neurobiology, learning about parallel computing, neural nets. The physics background obviously had a huge impact on my work in computer graphics.
Awesome. Parsha, do we want to just
David has raised his hand for a while now. If you want to unmute, you can then.
Yeah, David.
Yeah, thanks, guys. Hi, Pat. I'm a big
Hi,
fan
David.
of you guys' work. I grew up watching Toy Story and all those Pixar movies. I just want to say thanks first. And, as a layman, I have some background in mathematics and computer science, but, not anything too technical. So I think for me to understand some of the work you've done is already too late. I'm about 35 now. So I'm thinking about the younger folks. I have some younger nephews and maybe some kids in the future. And I just want to know if I were to, try to inspire them to retrace your steps, as someone as great as you who has done such great work. I would like to see maybe you have some key points of inspiration in your life that really pushed you to accomplish what you've done. I'd really like to hear your story.
Okay, thanks for that's a interesting question. I mean, I think one thing that has always driven me forward a little bit is finding things I'm really passionate about working on and problems I want to solve. So like to me in computer graphics, there was this challenge of like, could we make a full-length computer-generated movie? Like, is it possible? And I didn't actually think it was possible, to be honest. But I thought it would be really interesting to try. You know what I mean? It's sort of interesting why I didn't think it was possible, because I was trained in AI, and I remember reading Turing's paper. The one where he proposed this idea of an imitation game. The idea that if you could talk to a computer program, and if you couldn't tell it was different, it was not a person, then it would be intelligent. And I actually sort of always thought that was true of computer graphics, because if you're going to make a full-length computer-generated movie, you would have to not only have believable characters in there that you'd have to believe are living beings and so on, but you have to make a virtual world with plants and animals and scenery, and it'd have to look realistic as well as people behaving realistically. So it just seemed like even harder than the Turing test, because you'd have to be able to see it, which I think would be easier to tell it was fake compared to just typing text on a terminal. So I didn't actually think we'd be able to do it, and it was sort of an insurmountable problem. I mean, if we get credit for it, but you have to realize like thousands of people, really brilliant researchers, worked on all sorts of things to make it happen. Like, you have to figure out, you have to have characters. They have to move realistically. They have to be able to show emotions. You have to have good facial animation, but you have to have plants. You have to have mountains. You have to have water, and just think of everything you see in the movies. You have to have clouds moving, It's just simulating the entire world is just really an amazing challenge, and different people would work on different aspects of it, like water and clouds and skin and muscle and cloth, and it just was a huge effort by a lot of people. So it was a really challenging problem, and there was just no end to interesting things to work on. Like sometimes academics, they get real narrow in their interests, and they just sort of spend their whole life working on one small problem, one specific problem. And here we just had problem after problem after problem. You figure out one way to do something, then you have to figure out another way to do another thing, and it really was a great career choice because there were so many interesting problems to solve. And then the other thing I just think was just my basic, I learned math I taught myself programming, but I've always been sort of a back to the basics kind of person. So I just, I just knew like the physics, like, when I was working on rendering, I knew the physics of light, and I knew about light transport, and I knew about, materials and how they scattered light. I mean, there's just all these things I learned, all the math and CS and physics, which just, provides the platform. So if you train yourself in really fundamental skills and concepts, and then you get exposed to really interesting problems, you almost can't help but come up with great stuff. That's what I would say was characterized my life.
Awesome. So we have more questions in the chat that we can jump over to that are coming in. So Daniel Wexler asks, "Hey Pat, I'd be curious."
I know.
That's awesome. I'd be curious to hear your thoughts on the future of traditional rendering. The world of AI and neural rendering is the future of graphics just to provide sample data to an ML denoiser that also does uplifting, like the latest DLSS 5 release from NVIDIA? What happens to all the fantastic work done with signal processing and advanced sampling?
Yeah, well, that's a good question, and I'm not actively working in those areas, so I'm not sure of the expertise. But one thing, when I first started reading these papers, I can just say, like, there's a certain part of rendering which was like based on physics and so on. I tend to be drawn to that part because of my background. But then there was a bunch of like random heuristics, you know what I mean, that people just came up with, and some of the work with sampling patterns. Sampling patterns just means you have to send rays out at certain points inside of a pixel. Or another good example is what we do with this technique called path tracing, where you send a ray out into the world, it hits an object, and then it bounces around and it keeps bouncing around until it hits a light source. But you have to, in some sense, sample an infinite dimensional space of paths, right? Because paths can have any length, and every time you hit something, you can go off at any angle. And so you're going to take like a billion example paths, but there's an infinite number of them. So how do you pick the billion? And that's still a lot. But so you have all these heuristics about how to do the sampling, and there's no analytical solutions for that. So a lot of the techniques are very heuristic, and things like neural nets can propose methods for sampling paths. It's just sort of just like the game of chess, or even math these days. I mean, what the neural nets do, like say you're doing math, which is amazing right now, the new math stuff that's being done. If you're trying to prove a theorem, you have to apply some law, like commutative law, like A plus B equals B plus. So you have to apply a series of transformations to one side of the equation to get to the other side of the equation. Well, the laws are well known. It's just which law do you apply, and does it lead to the answer? And you can train a neural net to propose those moves. So you can combine this technology with traditional methods. I mean, I think the math example is even better than. And programming too. I use Claude every day now. So you can combine the neural nets to provide heuristics for help you solve really complex problems. And I think in rendering, that's a good one. And then and that includes things like interpolating or sampling or all sorts of things where there's often a lot of heuristics involved that, there's no right answer. It's a really hard problem. So I think that, that's going to be the way to go. Whether everything will just be based on, diffusion and neural rendering, I'm not sure about that. But it's pretty amazing what can be done. So I mean, obviously we'll see more and more, things like that. But I still think that 3D works. For example, I'm spending a lot of time doing 3D printing right now, and I can ask Claude to generate some scene description file, or even I use OpenSCAD, which is this programming language for designing geometry. It'll generate pretty good OpenSCAD, just like it can generate good C code. So I can combine generative models to produce traditional 3D assets as well. So I don't really know the answer. I'm just rambling here a little bit, but I think it's pretty exciting times because it helps us know like what's really we know about fundamentally and where we apply heuristics, and having AI help us apply heuristics more in better ways. It seems really exciting to me.
Amazing. That was a really great answer. I actually have a follow-up here. So there was a comment you made, and I wanted to kind of like pull a thread on there. You clearly have a very, very deep understanding of the fundamentals, having been so just an inaugural person in this space, I'd say. What do you think about using tools such as Claude and how it affects someone who's maybe still in the computer science program, learning about the subject? Does it help or hinder? Because I think there's this tension in the major right now where there's those students that are very pro for it and those that believe that all code should be handwritten and maybe just informed by AI, kind of like how we used to use Stack Overflow and Google in the previous to AI days to find solutions to answer questions that we had. And there's just this rift, I guess, and I'd love to hear your perspective as someone who's, I guess, a veteran in the space.
Yeah, that seems to be the question of the day. So,
yeah.
I mean, they're different. There are two perspectives on it. I've been programming my whole life, and I think I'm not a great programmer, but I'd give myself a very good. You know what I mean? And because I know great programmers, and I'm not one of them. I'm a pretty good programmer. I still program every day. I love to program. I just get great pleasure out of it. I wrote the first version of Tableau. I wrote a lot of the software, a lot of parts of RenderMan. So I love to program, and to me, it's just I just love to do it. Like it's a creative thing. I like to build stuff, and I just love to do it. But I've been doing it for a long time, and I also have been teaching it. And I was teaching the intro computer science course on systems programming, and it was a small course, and I got to help new students learn to program basically. And they can write some code, and I can look at the code and I can immediately see what's good and bad about it. I mean, I can they'll be like laboring over it for like days, and I'll look at it. Oh, there's the bug right there, I won't usually just point it out, but I'll look at the code and instantly see what's wrong with it, and then try to just question them like, well, are you assuming this is true? Or, but if you're new to it, if you don't really understand programming, how it works, it's a very different end of the spectrum, right? And so I find Claude awesome. I mean, because to me, so here's the way I'm using it these days, and I'm sure other people have better ideas, but like a lot of what I've seen students do, they just start writing all this code, start randomly. They just start typing in 100 lines of code, and they don't test it, they don't spec it, and so on. So when I use it, I think of the prompt as a spec. Like, what do I want? So you have to think really clearly. What are you trying to do? That's really good. You know what I mean? And a lot of people don't know what they're trying to do. They just start hacking away. They go off in random directions and just see what happens. The second thing is you have to read the code it generates. Sometimes you don't need to read all of it, but you just want to check it over. Like, does it make sense? And I think reading code is more important than writing code in my experience. So having it generate a lot of code that you read just seems really awesome to me. And I'm really good at reading code because I've worked in industry. You have to read code. You have to do code reviews. You have to read code. You spend more time reading code than you do writing code. So that's good. It emphasizes reading code over writing code. And a lot of writing code is pretty boring. So it just gets rid of all that boring stuff and lets you think about the higher level stuff. And then the final thing is you have to test and verify the code. And again, I know a lot of people. There's lots of people I know, especially older, they don't even test or verify. I require unit tests in my course.
Yeah.
And so, how do you know it works? And so, sometimes with more formal techniques nowadays, and that's a big thing. But you can maybe avoid it, because it can prove it's correct. But that's pretty rare. So you usually have to be able to. So anyway, spec, read, verify. And I think that's a better way to program than the way most people learn to program. So I think, you don't have to write the same code over. I don't have to read in another CSV file with Panda and do I've done it 100 times already. You know what I mean?
About syntax and memorizing structure, and you can think at more of a systems design level or architectural level. But I guess sorry, I'll close this thread up quickly too. But
No, it's
the
a good,
follow-up
it's
there
a
is,
question of the day for everybody, right?
yeah. It's like if I'm somebody who's going through computer science, a bachelor's, a master's, whatever it is, and I'm learning it, if I have teachers who are, forcing me or pushing me to just write from scratch code, but I never get to train the muscle of reviewing, reading, because in the position of being the teacher or a TA or something that allows you to like kind of review and share your taste and share your intuition. You can extend that to students if you chose to teach a classroom that way. But if you don't, then there's no one to do that. Where does the systems design thinking come from if that's the case, right? Anyways, this is just a very big question,
Yeah,
but
no, I agree. But I think but I don't quite really know, and I'm sure lots of other people are, know, probably in the audience may know better than me. If you're brand new to programming, you don't know how to read code, and you don't know what's good code and bad code. It's a little unclear to me how you learn it. You know what I mean with this stuff. But that's something people a lot of people are thinking about. And what do you really need to learn? How much programming? You have to do it a little bit, but you might be able to just do like we used to give these really complicated big projects and have people write a lot of code. Maybe we just give them lots of small exercises and just test their conceptual understanding.
Yeah, it's like give them 3 variations of the same function implemented. Which one is the strongest implementation? Explain why.
Like analyze it. Comment on it. Right. You know what I mean?
Yeah. Okay. Very cool.
Yeah. Like I went to this conference about math, and they're talking about all the mathematical proof systems, and there aren't many math people that actually prove theorems. I didn't realize that because I write code, but you think they prove theorems. No, mostly they read theorems and comment on them. So it's the same thing, so you just have to, by reading the theorems and understanding the structure of the theorem and commenting on it and, trying to understand the implications of it, that's, an interesting job. Yeah. So I think
also,
that applies
like,
to that program.
Yeah. Also, looks like Dr. Zvi Galil just joined, so thank you for joining us. If he's the creator of the OMSDS program and helped greatly in setting up the speaker series. So if you do want to jump in, say any words, feel free to at any time. All right, so let's move on to some of the other questions. We have a ton here in the chat. Jacob asks hey Pat, for those interested in computer graphics, do you recommend pursuing a PhD in computer science or related field like physics or engineering?
So as an undergrad or as a grad student?
That's a great question. Jacob, feel free to unmute if you want to add some comments to that. If you're around.
Okay. Yeah. Can you hear me?
Yeah, I can. Nice to meet you, Jacob.
Okay. Nice to meet you. Thank you. Yeah, I'm a master's student in Penn, and like they have a computer graphics master's program here, and I'm trying to figure out as I try to look into PhDs if I should stick with computer science if I'm very interested in graphics, or if it might be a better idea to get a degree in something like engineering or something more technical, because I'm very interested in things like physical simulation, a lot of the technical stuff that goes with graphics. So I wonder what you think about that.
Yeah, well, I mean, there are different paths in computer graphics, right? I mean, there's it sounds like you're interested in more like the simulation path. I mean, there's also like the engineering path, work on GPUs kind of thing, or work at Adobe on their software. And there's also the artistic path, right? And so it sort of depends on, what of that. But if you're interested in the simulation path, I mean, you definitely need to know the physics and math. I mean, that's one thing that's sort of unusual. Like if you're a PhD in computer science, you might not get exposed to all the math that you need to know for computer graphics. Like just, for example, just geometry. Like, I had to learn differential geometry, and that's not sort of part of a standard, computer science curriculum, or solving, differential equations. I mean, you might see that in scientific computing, but you might not see that in normal computer science. So you have to learn that. You have to learn that. And computer graphics nowadays is extremely, mathematical and algorithmic. So you have to somehow pick up that knowledge. Different people pick it up in different ways. Some people can just pick it up by reading books and, learning through projects, and other people want to take a lot of courses or, or it helps them learn it. So it depends on you a little bit, but you need to know it. One thing I have noticed is that if you're in, we have this computational math program at Stanford, which is really quite good. It used to be called, Scientific Computing Institute. And, but, they don't know much computer science. And I also know a lot of physics people, that spend their all day programming, but they really don't know computer science. I mean, by that, I mean, like, you'll say something like, oh, that's an order n log n algorithm, and they won't even know what that means. And if you look at their code, it's pretty bad, So, I mean, not learning any computer science, is because, I mean, at least in computer graphics, when I was in the field, you had to implement everything and try it out and so on. So if you can't, and we often wanted to put it into practice. So, you need to be a pretty good algorithms person and implementer. So I don't know what's easier to pick up, but it's sort of a challenge to have both sides of that, experience both sides of that and learn what you know.
Thank you. I mean, is it really useful if you're a person who's more in physics, but you're somebody that can program really well, or you're somebody who is in kind of programming, but you also know a lot of the mathematical basis? Is that like a pretty desirable skill to have if you can cross-platform?
Absolutely. I mean, not in all areas of computer graphics, but certainly in anything involving simulation. Absolutely. Yeah, it's very hard to find computer science students with backgrounds like that. If you just take a typical computer science student, they won't have the physics and the math background. And it's a certain kind of math. It's like continuous math. It's like solving differential equations and stuff like that. Yeah.
Well, thank you very much. I appreciate it.
Thank you. All right, we have a follow-up from Yifan Lee asking, hi, Pat. Can I ask you, do you see a convergence between computer graphics, simulation, and AI world models in the future? Essentially, do you see the ChatGPT moment of world models happening soon?
So if you just clarify a little bit what you mean by world models. I mean, just because
yeah, feel free to jump in, unmute, and share your thoughts there if you're around.
Yeah, hi Pat. Thank you for sharing. Yeah, I was wondering, like, the world model is like something that Fei Li they're doing right now to trying to let the AI model to understand the physical world at the moment. Yeah, rather than the big language model.
Right. Yeah. So I mean, I think that's very much an active area of research. Again, it's not my area of research. I mean, I first of all, I think that this approach is really going to be a valuable approach, because, like, even in computer graphics, we mostly just have, like, information about the physical world. Like, we have materials, and we have shapes, and we have light, and we have all this kind of stuff, and we have motion. But, there's a lot of other things that go into a scene. Like, are you trying to create a happy character, or you're trying to create a character of a given culture, or you're trying to make a building of a certain type? And all that knowledge is not in the computer. You know what I mean? That knowledge you have to provide as an artist. So I think, the thing which I find really impressive about even LLMs is that they have all this semantic knowledge, you know what I mean, about the world. And so when they produce things, like if you ask it to generate a 3D model for you, you can tell it, like, what country it's, make a T-set, from China. It'll know what a T-set from China looks like. And it's not just a bunch of curved surfaces. So I think this convergence of sort of the more, physical world models like we typically use in graphics with the more of the semantic world models seems really, really great to me. And, I think I don't know all the technology that are in play here, but, a lot of them, do like these multimodal embeddings where you embed, images and geometry and language all in the same space. I find that really appealing, that you can take these different modalities and combine them together. And then you add, things like, the control and all that. So, I mean, yeah, it's going to be amazing, as that stuff develops. But I think that's still, still a very active area of research. I don't really know, but it's not my area of research, so I'm not really an expert on it.
Yeah, thank you, Pat.
Amazing. So we have another question from Christopher V asking, "Hi Pat, have you personally used any of the video generation models like Sora 2, VO 3.1 from Google DeepMind, and so on? What is your opinion on these video models, and will they ever achieve Pixar level quality?"
Well, first of all, I've used a lot of image generation models, but I have not used the video generation models. I think I watch video generated by those models like every day. I mean, it's like unbelievable. Yeah, I think they will get. Yeah, I think they're going to get. I mean, they're already pretty amazing. I mean, the other thing about those models, I mean, like Pixar looks are sort of style. I mean, they're not like just photorealistic, right? They're cartoons, right? And I think a lot of the models I've seen have a certain cartoon. If you look at like a modern CG movie, they just have a certain sort of look that almost seems a little bit like the illustrator like looks at these video generators generate. The characters look like characters you see out of a DreamWorks movie or a Pixar movie. So they can generate stuff that looks like that. I haven't seen them generate a movie yet that has a whole complex storyline, but maybe I just haven't seen that. I don't know.
Yeah, this is a bit of like follow-up, I guess, personal one anyways, is I wonder if like years from now we'll have the same like computer science moment that happened with LLMs and the shift to reviewing code, but in other like fields like that one where people realize, oh, like maybe it's faster to be mass generating and reviewing than creating a frame by frame animation. And I don't know how much authority you have to speak on this topic, but I would
I think you're right. It's a very similar kind of thing. You could have it generate a lot of code, and you could go into some loop, and if it can do it fast. I mean, I went to a talk about this from somebody at Google recently, and it's still very expensive to generate these things. So I mean, it's although Claude Code can be. I was talking to somebody in the industry. Each developer is spending $20,000 a month using Claude, but I can imagine spending much more than that on this video generation. So it might not be totally economical right now to generate a lot of examples, but I don't know. It's hard to tell. But the cost of this is going to go way down. So it's possible.
Cool. So another follow-up from Abhinav asking, "Hi Pat, thanks for being a constant source of inspiration to researchers worldwide. Given your expertise, I'm curious, where is computer graphics and generative models going? What does the future look like from your perspective?" I guess we kind of touched on that, but
yeah, we've been let's say, with all due respect, I'm not really an expert on that particular topic, and and I don't like talking about the future of computer graphics that much. The one thing is, you don't want to ask me about the future. Okay, you should ask you should be thinking about the future, because you're going to make the future, not me.
Yeah. So another one from William Dormer. At what point do the advantages in rendering accuracy become outweighed by the cost in terms of electricity, time, and so on? Do people really care about hyperrealism in games, movies, and so forth?
Yeah, so there's two questions. One's the cost. And I don't think the cost of actually rendering a movie is the most significant cost. It's mostly the cost of all the people, and the time it takes to make the movie. And so when I was at Pixar, the cost was a huge issue. But I don't think it's as big of an issue nowadays. So I don't think the cost of rendering, it's mostly about the cost of the artists and the storytellers. But the tools, as everything gets cheaper, then you can do things in new ways. So I think the biggest issue is just trying to drive down the cost, and that's why I think generative AI is a really powerful tool for this kind of thing. Anything you can do to drive down the cost of designing and executing on the movie will be a really big thing.
Yeah, awesome. Question from Connor Fitzmaurice asking, "Hey Pat, do you believe the overuse of CGI in modern film is contributing to lower rendering quality, or is it just being used less smartly?"
Well, I agree with the overuse of CGI. I actually think it looks pretty realistic. I mean, there are movies made where they aren't, there isn't the care that maybe you would see in, DreamWorks or Pixar production. But overall the quality is pretty amazing. I mean, and there's so many different styles that you can choose. The hyper realism. I mean, the main driving force on a lot of realism, at least at Pixar and Lucasfilm, was being able to combine with live action. I mean, it wasn't so much that the goal was to be realistic, just to be realistic. I mean, that is an interesting goal. I mean, it's a challenge. But when Lucas, when they were, it all started with special effects, like for movies like Star Wars, and so they would have all this live action. And they would want to combine it with computer generated images, and that forced the development of a lot of techniques like motion blur and depth of field and all sorts of things like that, so that you could make it seem like it was generated by a real camera so actually a good movie to check out. There's a scene in this movie called Young Sherlock Holmes where this stained glass, this knight jumps out of stained glass is inside of a church, and it's live action with this knight. And that was one of their, that was the challenge. That was one of their first real, special effects that they generated. So a lot of it, I mean, the goal was not just realism in itself. I've never been, as much as I've worked on that, I've always liked other styles more than just a purely realistic style. I should talk almost a whole course on what is realism, in computer graphics. I mean, you can read art history books about realism, and many people have thought about what is realistic and what's not realistic, and whether realism should be a goal, and so on. I mean, one reason I was interested in visualization was that there was a different goal there. The goal was to do something useful to help people do their work. Like can they diagnose an X-ray better, or can they analyze data better? I mean, there was some specific goal that the imagery was supposed to help you achieve your goal. And so realism often is not helpful at all in achieving your goal. So I think there are lots of different goals in computer graphics, and I tend to like abstract art myself more than realistic art, so not that I don't like some for realistic art, but I think there's just so many different ways of making images that it's a little sad if the only reason people want to go into computer graphics is to make realistic images, because I think that's only a small part of the whole story.
Yeah. All right. So we have one more question from Sichem Zhao, and it says, do you think the lower cost of computer graphics introduction CGI introduction in the filming industry caused the taste fatigue for the general audience, or that the CGI realism is plateauing?
Well, yeah, to me, it's more about the kinds of movies. Again, I don't work in the film industry right now, but they seem to like to make certain kinds of movies these days. And fantasy, Marvel comic movies, or they seem to like certain kinds of action movies or violent movies. I mean, there's a certain style that seems to be selling. I think that's why they mostly use it. I mean, if they made more traditional movies, they might use it, less. So I don't really feel like I know exactly why they make the kind of movies they do, but and it's easier and easier to make those with the CGI. So there's sort of a self-reinforcing cycle there. But I don't know all the factors that influence their decisions on whether to use CGI or what kind of movies to make.
Thank you. And Zach, looks like you have a question. Jump in. Are you unmuted? Oh, one sec. I don't think we hear you, even though you're unmuted for some reason. So I'm still not able to hear you, unfortunately. Try rejoining and maybe that'll work. While you do that, I'm gonna continue with I guess a follow-up. So Simon Norris dropped a comment in the chat saying that I really appreciated the question/response about the LLM reviewing stuff as a senior in the computer science program. Certainly the question of the day. Thank you. the idea of focusing on learning to review is a really great perspective for those learning amidst these new coding tools. So for other, I guess that's the whole question, but my question to you, Pat, is like, is there any other wisdom you would want to share with people who are currently in the computer science programs or adjacent ones that kind of applies to this new age of doing things?
Well, I mean, yeah, well, that was my answer about coding. I'm still new to it. I mean, I've only been using it for, well, Claude for only 6 months or so. So I'm still learning, but I've been spending a lot of time thinking about how I use it and how I learn to program. I will just say about computer science, one comment I'll say maybe slightly tangential, but computer science is very interdisciplinary these days. I mean, so the way I teach computer programming is programming lets you accomplish things that you care about. Like for me, it was how to make images or how to model a nervous system or how to visualize data. I mean, there were things I wanted to do, and programming and algorithms was the skills I needed to implement those. But I still knew about that. In fact, why was I so interested in visualization data analysis? Well, my first job was actually working in a physics lab analyzing data, and plotting it, and and so I just knew that people needed, a lot of people spent a lot of time analyzing data, and they wanted to use plots and graphs and so on. So I mean, I've always been driven by like what I want to accomplish. So if in pure computer science, I mean, I guess you could just say I want to build an operating system to build an operating system, or a compiler to build a compiler. But I've worked a lot in programming languages, and I like to build domain-specific languages that let me do certain tasks really easily. And so when I build language technology or compiler technology, it's always been to, enable something. Or GPUs. I worked on this language called Brook, which was the forerunner of CUDA. And it was really just because I wanted to harness the power of the GPU. You know what I mean? I wanted to figure out how to bring all those cycles to bear on problems that I wanted to solve. I wasn't just trying to learn about compilers for their own sake. Now, other people have different perspectives on that, but I think that's just something to think about in computer science. Like, why are you interested in it? What do you want to accomplish? And depending on your interest, you'll want to combine computing with other fields, computing in X kind of thing. And I think that's a really healthy thing for the field because it just brings in a lot of new ideas.
Zachary, do you want to?
Marcia, does my sound work now? Or
Yes,
no?
it works now.
Yes.
Yep, you're good.
So I had a question because we've had a lot of Turing Award winners. Do you have any stories of any, like, I don't know, funny interactions with any of the Turing Award winners that we've hosted? Like maybe like Don Knuth or anyone, any like stories that?
Short, funny stories. Well, Don Knuth, we were born in the same city, Milwaukee, Wisconsin. And, I mean, I have so much admiration for him. I'll just tell you one great thing he does every year pretty much is he gives this, he calls it the Christmas tree lecture. And it's almost always about trees, like in computer science terms. And, it's just one of the most popular events on campus. In fact, I've been walking on the campus and there are literally people have just flown in from New York to attend this lecture. But, he just gives these really awesome lectures about all sorts of topics. And he tends to study things that, aren't in, not trendy. So they're always really, really stimulating. But he's been a great guy. And I count him as a computer graphics person because, he designed tech, obviously. He's a huge fan of typography. He designed this program called Metafont, and he's into the art of it, the design of fonts. He's into the design of mathematical typesetting, the layout. He's just meticulously into it. So I always considered him the founding member of the computer graphics program at Stanford.
Awesome. I think there's one more question now in the chat, and then I think after that we'll wrap things up. So Christopher asked a follow-up question saying, do you think the current war will propel the next phase of AI and computer vision? To cite a historical reference, the Vietnam War helped propel radio and cryptography advancements.
Well, I do think, AI weapons are one of the scariest things that I can imagine. So I mean, I just hope we don't devote, build all these. Yeah, I mean, I'm old enough to have read a lot of science fiction in my life, and drones, and just armies of drones are not a great future for humanity. So I hope that's not what comes of all this AI. I hope we can think of something better to do with it.
Yeah. Okay.
Okay, Parsa, I think we're should wrap things up.
I think it's a good
Okay.
time to wrap things up. And Pat, if people have follow-up questions, where can they find you if they want to reach out? If you're comfortable sharing, of course, you don't
Sure.
have to.
I mean, I usually answer my email. I mean, depending on how many questions I get.
Okay.
So you can just send me an email. I think my email is pretty easy to find. It's on your website,
Yep.
I think. Yep.
Yeah. Thank you so much.
Yeah,
All right,
so
give a
thank
round
you
of
so much
applause.
for coming out. If we can get a big virtual applause for Pat, be awesome.
Thank you,
And,
everyone.
we always love to give our speakers a Godiva chocolates as a token of appreciation. Parsa will follow up with you to see where we can send those over. And yeah, thanks everyone for coming out. It was awesome.
Okay. Thank you, everyone, for attending. Yeah. Great question.
Thank you. Have a great day,
Steve.
everybody. Thank you, Pat. Take care. Bye-bye.
Yeah.
Bye, everyone.
Bye. Thanks.